Hello everyone. We are starting with the topic of circles. Our focus is the P1 syllabus, the Pure Math P1 9709 syllabus, and circle is a new chapter that has been added. Now, what exactly do we know about circles from our past experience? We know the different parts of a circle, the circumference, the diameter, the radius, the key components that make up a circle. We are also aware of the fact that if there is a line that passes through the center, that is definitely the diameter, but diameter is technically a chord. Any 2 points on the circumference can be joined by a line. Such a line is called a chord, and diameter is such a chord that passes through the center, the biggest chord in a circle. Then we are also aware of the different terminology such as arc length, which is part of the circumference, sector, which is that pizza shape section of a circle, and segment. Now, if we look at the new P1 syllabus, circles fall under the category of coordinate geometry. Let's focus on the box. The thing that we need to do is that we need to understand the equation of a circle, and we need different algebraic methods to solve problem involving lines and circle. And in this scenario, we would also be taking a little bit help from quadratics, something about completing the square method. Now, in this first lecture, in this first session, we are focusing on the equation of the circle. We would focus on the completing square method, the concept of discriminant, and applications in equation of a circle. Now, if we look at this diagram, that if there is a point P, x comma y, if I draw a circle whose center is the origin, and if I apply Pythagoras theorem, then we get the simple equation. The magnitude of that vector OP, or I can simply say the distance of P from the origin, that is denoted by the symbol R, that is equals to x square plus y square. That's how the equation of a circle is obtained. And if the center is not the origin, then the equation is given below: x minus a whole square, y minus b whole square, that is equals to r square. This is the standard equation of a circle. Now, let's look at a simple question. If the examiner asks you, write down, you find the equation of a circle with center minus 5, 7 and radius 6. So there is nothing much to calculate. All you have to do is to place values in the right position. So the x coordinate of the center is minus 5, the y coordinate is 7, the radius is 6. X minus h whole square, y minus k whole square is equals to r square. Some syllabi, some people, they use the symbol of a and b for the center of the circle. In some other syllabi, in some other books, the symbol used are h and k. So x minus h whole square, y minus k whole square is equals to r square. All you do is to plug in the point, and hence you write the equation of a circle. There is no need of expansion of this particular equation unless it is needed in order to solve some simultaneous equation. Let's look at another question. A question that is based on completing the square method. So we need to understand this method first. What exactly is the completing square method? A quadratic expression, which is written in the form ax square plus bx plus c, can be compressed into a smaller form. There are two x terms. One is the x square term, the other one is the x term. Two terms involving x. One involves x only, the other involves x square. And of course, there is a constant. Now, completing square method is transforming this thing into a compressed form. A linear bracket with a square on the outside, and then a plus minus a constant. The first step in doing the completing square method is make sure the coefficient of x square is 1. What happens if it's not 1? you have to take that coefficient common throughout the equation. Second step, the first two terms as it is, push the constant to the right. First add, then subtract square of half the coefficient of x. And now we are dealing only with the coefficient, and the example would come a bit later. Now the first three terms, ax square plus bx plus that constant square, you compress it. The logic of this compression will be dealt more in the concept of quadratics, but right now we are simply focusing on circle. So completing square is a subsidiary of that concept. That is why we are only focusing on the working of it. Rewrite the first three terms as a perfect square. Let's look at the first example. The expression given to you is x squared plus 6x plus 10. Now you have to compress it. The rule is first add, then subtract square of half the coefficient of x. Step 1 is already skipped because the coefficient of x squared was already 1. What is the coefficient of x? 6. What's half of 6? 3. So you first add 3 square, you subtract 3 square. Now the first three terms is simply the expansion of x plus 3 whole square. So you compress it. These three terms becomes 2. So x plus 3 whole square. Simplify the other two terms, and what do you get? X plus 3 whole square plus 1. This is called the completed square form. Another example. 2x square plus 8x plus 18. Take 2 common out. And repeat the same process as the previous example. What goes in these purple brackets? 2. X squared plus 4x plus 2. What can this be written as? X plus 2 whole square. Now remember, there is a constant on the outside. The constant not only would multiply with the first bracket, it will also multiply with the constant. So therefore you would get this expression, and again it's in the completed square form. Now we are basically changing a general equation, a quadratic equation, ax squared plus bx plus c into the standard form. Now if we look at this question of quadratics, actually before that we are converting it. So we are starting off with the equation of a circle. X squared minus 10x, y squared plus 12y is equals to minus 12. Push the constant on the other side of the equal sign. With x squared minus 10x, you repeat the same process as in the previous two examples. With y squared plus 12y, the same concept is repeated. First add, then subtract, first add, then subtract. Square of half the coefficient of x as well as square of half the coefficient of y. Now let's look at the process. X minus 5 whole square, y plus 6 whole square, and now take all the constants on the right hand side. Isn't this the equation of a circle? X minus 5 whole square, y plus 6 whole square is equals to 7 square. Always compare it with our standard. Don't be deceived by the looks. X minus 5 and y plus x. The standard is x minus h, y minus k. The center of the circle is minus 5, 7, and the radius is 7. Another example. This time, the coefficient of x square is 2, the coefficient of y square is 2. This particular question, I have solved it in two ways. In the first method, I have taken common out, but left the 2 as it is. Same concept inside the brackets. Simplify on the insides first. And now when you open up the bracket, 2 is multiplied with each single thing inside the bracket. Now this time, the two brackets are there. All the constants have been shifted to the other side. And this is the equation of a circle. What is h? 2, what is k, minus 2, what is radius of the circle, that is square root of 13 over 2. Another alternative approach, maybe an easier approach, is that first divide by throughout. First divide the whole equation throughout by 2. And in this way, you are left with a better option of simplifying. Of course, you would end up with the same answer. Okay, more on equation of a circle. Something like, find the equation of a circle center 4 minus 3, which passes through the point minus 2 comma 5. Now the center is given, any other point on the circle is given, and the radius is unknown. So first thing first, plug whatever information you have in this equation. I'll first plug in the center. There are two methods. The first method is, center is there, point on the circle is there. Don't we know that the distance from the point on the circle to the center is called the radius? So therefore, I first find out the radius and then just plug in the values. That's it. Second method is, plug in minus 2 comma 5 in place of xy, because xy is any point on the circle. And this method boils down to exact same thing as the first one. It's just you are doing it without realization. Without realization of the fact that the distance from the center to any point on the circle is the radius. So any which way you like, you would end up with the same thing. Now, another question. The line cuts the x-axis at A and the y-axis at B. Basic coordinate geometry. When a line cuts the x-axis, y-coordinate is 0. When a line cuts the y-axis, x-coordinate is 0. The point C is the midpoint of the line AB. Find the equation of a circle that is center C and passes through A and B. That means once I get hold of the coordinates of A and B, the midpoint of AB is the center, so use the midpoint formula. The distance from A to B is the diameter. Half of diameter is the radius. That's one approach. The other approach is find the distance from A to C, that is the radius. Alternatively, you can find the radius from C to B. So you have the radius, you have the center of the circle. There is nothing more that you are looking for. Just go through all the steps. First, you find out A, then you find out B, then the midpoint, which is 5 comma 2, and then the radius of the circle, and hence you write the equation of a circle. Last part, show that the circle also passes through the point 0, 0. Plug in 0, 0 in place of x and y. If both sides are equal in that circle equation, definitely the circle passes through this point. Discriminant, another concept. What exactly is a discriminant? When we look at a quadratic formula, the expression inside the square root is called the discriminant. If the expression inside the square root is positive, you end up with two values. If the expression inside the square root is 0, you only end up with one solution. If the expression inside the square root is negative, you end up with 0 solution. When a quadratic curve cuts the x-axis at 2 points, we say that there are two roots. Roots is an alternative term for the x-intercept, for the solution of the equation. So two roots. When b square minus 4ac is 0, you end up with only one root. And when b square minus 4ac is less than 0, you end up with 0 roots. Now the two roots, you can see it for yourself. So we can say that the roots are real and distinct. One root, a quadratic equation should have two roots. But since only one is appearing, we generalize it by saying that the roots are real and equal. Real because we can see it, equal because it has been repeated. And since it does not cut the x-axis, there are no real roots. Now, the same concept which a quadratic equation has with the x-axis, the relation between a quadratic equation and the x-axis, that can be translated into a quadratic equation in any line. You simplify that equation and the same concept can be applied. Now, let's look at this question. Find the set of values where the line intersects the curve at two distinct points. make a single equation out of it, a single equation in terms of x, a single quadratic equation, meets at 2 points. That means b square minus 4ac is greater than 0. Simply solve this equation and you get the answer k is lesser than minus 1. Another question. A line has the equation, a curve has the equation. Find the two values where the line is tangent to the curve. Tangent means meeting at 1 point only. So if it's tangent to the curve, that means b square minus 4ac is equal to 0. The same process as before. Now the new additional thing which they're asking is that, hence find the coordinates of the point where the line touches the curve. Now we know that we obtain two values of k. One is positive 1, the other one is negative 1. When k is positive 1, you plug in that equation and that equation simplifies to x minus 2 whole square. And you already know for sure that since it's a tangent, you would end up with one answer. So the answer is x is equals to 2 and the corresponding value of y is also 2. When k is equals to minus 1, you get another set of points. Now, circle again. We understood the concept of discriminant. We understood the concept of completing square method from the quadratics. Now we would be applying the concept of discriminant with respect to a circle. The same concept is there. Quadratic curve touching at 2 points, that's the same thing as circle intersecting at 2 points. Now, how can it be the same? Because when we take a circle equation and when we take a line equation and when we simplify it, what you end up is a quadratic equation. And since it's a quadratic, you can apply the concept of discriminant. Now, let's look at this equation. Find the coordinates of the point where the line meets the curve. Does it specify at how many points does it meet? It could be 1 point, it could be 2 points. First, the equation is simplified. You get a quadratic. You simplify to the fullest. You do middle term factorization. And they are asking for the number of points. Now, there are two approaches to this. One approach is you just solve it simultaneously and you end up with two answers. As simple as this. The other approach could be when you have x squared plus 3x minus 10 equals to 0. And if they would have simply asked you, show that the line meets the curve at 2 points. So what would you have done? You would have calculated b squared minus 4ac. If it comes out to be greater than 0, meets at 2 points. If the question would have been worded in such a way that the line meets the curve at only 1 point, then b squared minus 4ac would be equal to 0. But in this particular question, they're actually asking for the coordinates. So you have to solve it simultaneously throughout the whole question. Another question. Show that the line does not meet the curve, does not meet the circle. What do you expect would happen? You would form an equation. It would be a quadratic equation. And you would try to simplify it. It won't factorize. Now you're desperate and you would be going for the quadratic formula. The quadratic formula won't give you any answer because the discriminant is negative. You cannot take square root of a negative number unless you study complex numbers in P3, and that would be a year later on. For right now, what you need is that you get a quadratic equation. The b squared minus 4ac is negative. No solution. What's the implication? Line does not meet the curve. Now, this is the type of question that usually comes in the exam. The line with the equation meets the circle at exactly 1 point. Find the two possible values of k. Circle meets line at exactly 1 point. In other words, line is tangent to the curve. Simplify, get a quadratic. And what? B squared minus 4ac should be equal to 0. Now this time the answer is in the surd form. Surd form means the exact form without using a calculator, without evaluating the square root, leaving the answer in the exact form. Now in the first lecture, we have studied the very basics of circle. We studied the equation of a circle, both the forms. We studied about completing square method, the concept of discriminant applied to a circle, And that is so far so good for the first equation. Go through every single step, understand in its fullest, and then in the second lecture, we would be dealing with some of the angle properties, geometric properties, tangent properties of a circle.